Next we go for instruction set. Here the instruction set of PIC microcontroller will be entirely different from your 8085 microprocessor. Okay. ஸோ இங்கே ரொம்ப முக்கியமான ரெஜிஸ்டர் பார்த்தீங்கன்னா சோர்ஸ் ரெஜிஸ்டர் அண்ட் ஒர்க்கிங் ரெஜிஸ்டர். சோர்ஸ் ரெஜிஸ்டர் வில் பி ஸ்பெசிஃபைட் as எஃப். Working register will be indicated as W. Okay. This will be clear in your textbook. Okay. I will give textbook for you. Raj Kamal கிடையாது. Raj Kamal வந்து first two unit will be covered in Raj Kamal book, but third unit will be covered in your um, Peatman. Okay, design with the PIC microcontroller book Peatman. This is one of your textbook. Okay, totally three textbook available in your syllabus. So in the third book will give you entire details of PIC microcontroller. Okay, so in Raj Kamal, PIC microcontroller will not be covered. So இதில் எல்லாமே இருக்கு clear-ஆ. I will give this book. I will send to you both in vMedulife as well as in group. So இதில் clear-ஆ தெரியும் BCF. Okay, but in PPT this is somewhat glare. So BCF FB. So FB going to be act as a operand mnemonic BCF. So what is BCF? Okay, see, one instruction will have mnemonics and operand. Okay, so the corresponding code will be opcode. That code value will be in hexadecimal value. I think you all enter hexadecimal value in the microprocessor kit, because the kit that is machine knows only the machine value. Okay, or machine language. Okay, this is manual language, man known language. Okay, mnemonic with operands. We only know what is BCF, but kit your device will not know about the BCF F comma B. The corresponding code word will be applied in hexadecimal value. After that only it will be doing performance. Okay, based on your code value. So BCF, F comma B. So clear, C stands for clear bit. Okay, clear bit. BC, clear bit. Which we're going to be cleared? Register F. F register going to be cleared. F is nothing but source register. Okay, so the bit value will range from 0 to 7. So the number of timing cycle taken for executing this instruction will be 1. Whether this instruction affect the status bit is nothing but your status register. So your status register is CPU register, one of the CPU register. So this status register la irka bits edavadhu affect பண்ணுமா, that is given in the table. So nothing will be affected in the status register. Then BSF F comma B. So BS stands for set bit. So where you are going to set the bit? In register F. Okay, that is F comma B. Here the B ranges from 0 to 7. Okay, operand B on the range value is 0 to 7. Cycle, number of cycle, timing cycle taken to execute this instruction is 1. Then clear W means clear the working register W. Okay, so on clearing the working register, your status bit 0 bit will be affected. That means 0 bit will be loaded with 0, because here you are going to clear the working register, that is result storing device. Working register will be acting as the accumulator is the result storing device. So result 0 and இங்கே 0 bit வந்து set ஆயிடும். Okay, then clear F. So you are going to clear the F register, that is source register. and then move LWK. So move literal value to W. Okay, you are going to move the literal value to the W register, and then move WF. So you are going to move the W to F register, and then move F comma F of W. So here you are going to move the F to uh, F or working register. Okay, small f to capital F register or F. Here you are going to select either capital F only will represent. One more thing you have to understand, capital F will represent source register, W will represent a working register, small f will be file. Okay, sorry, small f will be file register. Okay, capital F is source register, W is working register, small f stands for file register. Okay, swap f. Suppose what is swap? இது வரைக்கும் move clear தான் வந்திருக்கு. What is swap? Swap means you are going to interchange between the register. The data will be interchanged between the registers with the small f or capital F, or with the working register. Okay, this will be swapped. These two registers will be swapped. Swapped. File register with the source or working register, and then increment F. F comma F of W. Increment the F register, putting result in F or W. Decrement F, putting result in F or W. And then what is this? COM. Complement F. The result will be put in F or W. And LW. So and LW nandale literal value. Okay. So you are going to do the and process. Okay, and operation with the working register by the given value. Okay, and then and W with F by putting the result in F or W, and then inclusive or exclusive or. Okay, so IOR XOR, inclusive or exclusive or, and then add. So this is the direct data will be added with your working register, and then adding W and F, that is file register, and then result will be stored in either source register or working register. Then subtraction process similarly for that sub LW, sub WF, and then what is this? Or LF or RF. This is nothing but rotate. You'll be learnt in microprocessor rotate instruction. Okay, you are going to rotate through the left. Okay, rotate left, what register? File register. Okay, so copy F into a capital F or W, and then rotate F or W left side through the carry bit, means including the carry bit you will be rotating left side. Okay, so only one time you will be rotating. Idu vandu rotate right. Okay, what is this? BTFSC. You are going to test bit. Okay, this is used for testing the bit. And then DECFS is that this will be decrementing the register, and it will skip the zero value. Skip when you are getting the zero value, the instruction will be skipped off. So decrement பண்ணிட்டே வர ஒரு range high rangeல இருக்கு, you are decrementing the value. If it comes zero value while you are decrementing, means then this instruction will be skip off. Okay, that is the meaning. அதே மாதிரி incrementலயும். Okay, INC na increment, and then go to label jumping. Okay, you are going to go jump into the address given here. Okay, the label will be given. Label is that A, B, anyone, anything else you can label the name, and then call அதே மாதிரி தான். You are going to call some address. Okay, that means you are calling some subroutine program to execute in the main program. Okay, and return. So return is used where you are returning from the subroutine program. Okay, subroutine program is nothing but a small program which is called in the main program. Okay, and then return LW. So this literal value will be used for returning purpose, and then return FLE. So this will be used return the interrupt service. Okay, interrupt service means uh, any external device or any other part of the device will be requesting the processor for executing. Okay, or asking for request to do some task. Okay, so the your processor will stop doing the main process and it will be serving the do service for the interrupt. Okay, interrupted device. And then clear watchdog timer. This one, watchdog, clear watchdog timer means your timings say timers will be cleared. Sleep, this will be in the sleep mode, standby mode. This NOP is no operation. Okay, to stop the program or process, you will be executing this instruction NOP. So these are the instruction. Very few instructions are present in kit microcontroller. In microprocessor, you will be having more instruction. I think 80, 90. But here, only minimum instructions will be used for all the process. So then next, single bit manipulation. So single bit manipulation la இந்த ரெண்டு instruction வரும். Okay, already I explained what is BCF, BSF. Okay, so the say these two bits will be coming under the single bit manipulation. அதே மாதிரி clear மூவ்க்கு இந்த move instructions, swap, clear இதெல்லாம் clear move instruction கேட்டா you have to write all this. ஸோ நீ யோசிக்க வேணாம், டேபிளில் கொடுத்ததே தான் இங்கே கொடுத்துருக்கான். இந்த டேபிளில் ஓவராலாக கொடுத்துருக்கான், இங்கே வந்து கிளாசிஃபை பண்ணியிருக்கான். ஸோ ஃபர்ஸ்ட் டூ இன்ஸ்ட்ரக்ஷன் என்னென்னா சிங்கிள் பிட் மேனிப்புலேஷன் இன்ஸ்ட்ரக்ஷன். அப்புறம் மீதி இந்த மூவு இதெல்லாம் இருக்கு இல்லையா, அதெல்லாம் பார்த்தீங்கன்னா கிளியர் ஆர் மூவ் இன்ஸ்ட்ரக்ஷன். இன்க்ரிமெண்ட், டிக்ரிமெண்ட், காம்ப்ளிமெண்ட் எல்லாம் இது இன்க்ரிமெண்ட் டிக்ரிமெண்ட் இன்ஸ்ட்ரக்ஷன்ஸ் இந்த டேபிள் சொன்னலையா அதெல்லாம். அப்புறம் மல்டிபிள் பிட் மேனிப்புலேஷன். மல்டிபிள் பிட் மேனிப்புலேஷனில் இந்த அண்ட் ப்ராசஸ் லாஜிக்கல் ஆப்ரேஷன்ஸ் இருக்கு இல்லையா, அது எல்லாமே மல்டிபிள் பிட் மேனிப்புலேஷனில் வரும். அண்ட் எக்ஸ்ஆர், இன்க்ளூசிவ் ஆர், எக்ஸ்க்ளூசிவ் ஆர், everything will come under the multiple bit manipulation. Addition subtractionல add subtract. Okay, அந்த instruction வரும். ரொட்டேட்ல இந்த ரொட்டேட் லெஃப்ட் ரொட்டேட் ரைட் கொடுத்தோம் இல்லையா,